All right, so in preparation for Wednesday's test, remember we're having a test on Wednesday, okay? And that packet is due on Wednesday, and any formative corrections that you may have fixed are due on Wednesday, okay? So, solve this one by Cramer's rule, solve that one using matrices, and then we will check them on the calculators, okay? So, Cramer's rule on the first one says, if I'm going to solve for x, oops, come on now. If I'm going to solve for, well, tap the brakes, come on. Why is it not? Ay, caramba. So if I'm going to solve for x, that's going to be, I'm going to, first, I like to write down the denominator. 7, 1, 3, negative 10. Then because I'm solving for x, I'm going to replace the x coefficients with negative 17 and positive 24. Multiplying that out, so multiply those two together, that gives me 170, and then I subtract those when I multiply them together, so that's minus 24. Same thing on the bottom, multiply those two together, that's negative 70, and then subtract those two when multiplied together, so that gets me minus 3. So that would become then, what's that, 146 on top and negative 73 on the bottom. So that tells me that x is negative 2. Okay. Now, I could substitute negative 2 back into one of my equations, or I could reset up Cramer's rule. So y here then would be equal to 7 and 3 there, but now this is going to be negative 17 and 24 there, and the denominator here is going to be negative 73. So that is 168 minus negative 51 all over negative 73. That gives me 209. Nope, excuse me, 219. Over negative 73. So y then is equal to negative 3. Agree? So we get either the point negative 2 comma negative 3, or x equals negative 2 and y equals negative 3. Yes? Okay. All right. Then it said solve the second one here by using matrices. So the first thing I'm going to do is I'm going to write down my matrix equation. Negative 4, negative 1, 7, and 2. X and y equals 2 and negative 5. Okay. Then what I need to do is I need to find the value of this determinant. Or I shouldn't say, excuse me, yeah, well I need to find the value of the determinant. So the determinant is going to be negative 8 minus negative 7. So that's going to be negative 1. Is the value of the determinant. So then the inverse is going to be 1 over negative 1 times the matrix, and I take and I switch on the main diagonal, and I negate on the other diagonal. So that's my inverse. And then I can solve for my variable matrix by multiplying my inverse matrix by my constant matrix, which was 2 and negative 5. So that's going to be negative 1 times 2 times 2 plus 1 times negative 5 and negative 7 times 2 plus negative 4 times negative 5. So that tells me then here that my x is equal to 4 minus 5 is negative 1, but times that negative 1 on the outside is positive 1. Negative 14 plus 20 is 6, times negative 1 is negative 6. Or we could have written it as, that. Okay? Now, what I would like to show you is how to solve both of those using the calculator and a shortcut on how to do it on the calculator. Okay? So, the first thing that you have to do on the calculator is you need to have a calculator page open. Okay? Now, my first one, the way we did Cramer's rule, was the 7x plus y equals negative 17 one. Okay? So on the calculator, I am going to input a 2 by 2 matrix. And that's going to be my coefficient matrix. 7, 1, 3, negative 10. Okay? Now, if I fast forward, if I'm thinking about it the matrix way, this here is the inverse times the constant, right? To solve for it. So I need to take the inverse of that matrix. Well, I tab out of it and I raise that to the negative 1 power. And that's how we find the inverse. But don't hit enter yet, because I've got to multiply that by the constant matrix, which was a 2 by 1 matrix. And that one was negative 17 and 24. Now when I hit enter, I should get x is negative 2 and I should get y is negative 3. And I do. Okay? You can skip right down to that ending part. So the second one, the negative 4x minus y equals 2, and 7x plus 2y equals negative 5, that one would have a 2 by 2 matrix, and it would be negative 4, negative 1, 7, and 2. I'm going to raise that to the negative 1 power, and then multiply that by a 2 by 1 of 2 and negative 5. And there it is. here's where things went all cattywampus in the first class. But you guys are on the ball. Oh, it's not liking it today. I don't like it. So I'll put it in. I'll put that in postscript then. Okay? But those were our answers. Okay? Now, the question did arise earlier today about some special cases when you're solving systems of equations. And there's always two special cases when you're solving systems of equations. There's infinite solutions and there's no solutions. Infinite solutions is when you have the same line. Okay? Where both lines end up being the same. No solutions case is when you have parallel lines. Okay? Now, in elimination or substitution, you're going to have here, you're going to have a true statement with no variables. If it's an infinite solutions case. So you get something like 0 equals 0. Or 17 equals 17. Okay? It will be a true statement, but there won't be any variables. Over here, it would be a false statement. Without variables. Okay. When you're graphing, infinite solutions obviously would be you would when you graph two lines, you only see one on your graph. When you graph no solutions case, you would graph two parallel lines. Okay? When you are doing Cramer's rule, and it's an infinite solutions case, you will get 0 over 0 for your fraction. Let me back up and let me show you. So when you solve this here with Cramer's rule, down here in this step right here, you would get 0 over 0, and that would make it be infinite solutions. Okay? If you have a no solutions case, you're going to get some number over 0. Okay? Those are the easy ones. The a little more difficult one is matrices. In matrices, your determinant is going to equal 0. So you would have 1 over 0 out in front of your inverse matrix, okay? Which doesn't work, because 1 over 0 is an undefined number. Okay? And then you have to inspect the equations. And what I mean by that is you are going to have to look at your two equations. And you're going to have to determine if they're the same or if they're different. If you can multiply one of your equations by a number, and it comes out to be the exact same equation that you have for your second equation, that's an infinite solutions case because they're the same. If you can't, then it's a no solutions. Okay? So you got to do a little bit more work with the solving by matrices method. Okay? Hopefully that cleans things up. Now, Wednesday is your test. We talked about that already. Okay? Your homework packet is due. Okay? On Q8, that's calculator work. Okay, well, that's working with the matrices and adding and subtracting and multiplying matrices using the calculator. Okay. Q9 is using the calculator to solve systems of equations, kind of what we just showed. Okay. For the 3x3, there's two 3x3s on the front side. For those two, we want you to use the calculator. Okay. For the other two on the front side, the 2x2s, solve them like normal. And then just check your answer on the calculator. Okay? On the back side is where things gets interesting on Q9. Okay? The back page of Q9 has some 2x2s, if I'm not mistaken. Yeah. Okay. Has 3 2x2s, a 3x3, and a 4x4. So again, you can do the 3x3 or the 2x2s. You can do those by hand using matrices. Check them on the calculator. But then those bottom two you gotta do on the calculator. Okay? Handle? Okay. And it's all due on Wednesday. Okay. That's all I got for you today. Thanks for playing along.